Wasabi, you guys. Welcome to Integration Bee Training for Advanced. This is 10.2, which means that we're still learning about periodicity. And in this section, we're going to be learning some trickier stuff with periodicity. Some real Integration Bee integrals. Okay, now that we all know how periodicity works, a lot of you might guess, oh, I'm just going to guess 0. Well, you are incorrect, and you would have been eliminated. Okay, so be very careful. Again, check for squares. We must check for squares. It is very important that we check for squares. In this case, I noticed that we were potentially going to have a square because we have x and 2x. You know, x plus 2x equals 3x, which is what we have here. So we might potentially have squares. Okay, so let's go ahead and check, right? So cosine, that's going to be a cosine identity. So that's going to be, we start with minus. So it's x, x minus 2x. Cosine's even function, so it doesn't matter the negative. And this is plus cosine of 3x. Okay? And you notice that we have cosine 3x here. So we do have cosine 3x. We do have squares. Okay. This and this term, they're different, so they're going to cancel each other out. Okay. So what we have is we pretty much have cosine square 3x. Okay. And then that's going to equal to what? Half. A half plus cosine of 6x. That's going to cancel out, because that's going to become a sine, right? A sine, and then sine of pi minus sine of 0. They're going to cancel each other out. That term right here is 0 by periodicity. So, be very careful. I noticed something. That's a half. Okay, trig identity is the biggest, the most common mistake that we tend to forget. A trig identity is a half. And so now, with this half following up, our actual answer is pi over 4. Okay? Be very careful. Don't be like me. Right? That's the dangers of being too fast. Okay? Alright. Let's try another integral. So this integral is from, I believe, it's a similar integral from the UC Berkeley Integration Bee problem from 2020. And in this case, we can see some symmetries here, right? This here and this distribution here, odd function. So because we're going to have some even functions, we have what's left with cosine, or we'll abbreviate this, cosine square of 3x, then minus sine 2x with 2019x. Okay. Now from here we know this is 0. We know this is 0, so this whole term is going to cancel out. And now here we have, I'm going to bring in the 2 in, so we're going to have like something around like cosine whatever. This is, that's going to become 0, from 0 to 2 pi. So the answer for this whole integral is going to equal to 2 pi. You see how fast that was? Rather than actually doing the whole trig identity thing. So periodicity, it's very fast and something that you must get used to at an advanced level. Alright, you see how intimidating this is? Right, we have 3 terms being squared. Alright, now this looks nasty, right? But don't freak out. Okay? Don't freak out. Right, let's consider each like A, B, and C. Right? When we have A plus B plus C and we're squaring this, we're gonna get something like A times B plus B times C, A times C, whatever, and we're gonna have a bunch of these, whatever, right? And that these terms, because they're different coefficients, all of them are going to be 0, right? Except for what terms though? The only terms that won't be 0 is a squared plus b squared plus c squared, right? So those are the only terms that will not be 0 by periodicity. So because of that, this is technically the same integral as from 0 to 2 pi sine square plus sine square of 2x plus sine square of 3x. Again, you could abbreviate it. I don't know, for some reason I just naturally write it, right? We know that when we use the trig identity, the cosine portion is just gonna be 0. So, moving on, right? Moving on, we know that we're gonna be left with 1/2, 1/2, 1/2, because the cosine term is gonna equal to 0 by periodicity. So, because of that, we're pretty much done. Right, this is 3/2 times 2 pi. So our answer is 3 pi. Okay? Again, it's very, very fast, very tricky mental calculations. But, you just have to get more comfortable. We have another intimidating integral here. We have cosine plus cosine squared plus cosine cubed to the 4th, to the 5th, and to the 6th power. Okay. But how on earth are we going to deal with this? Alright, so it's a little tricky. Right, now we're getting to some tricky stuff. I want you to realize, well, we know this is going to be 0. Okay. But what about cosine cubed, cosine 5th, right? Notice that if we have an odd number power here, this is the same thing as cosine of x 1 minus sine square, right? And notice that here, this is also going to be what? Cosine of x. I'm sorry. Let me rewrite it this way. Cosine square. And we have cosine of 1/2 plus cosine 2x, right? This and this, that's going to be 0. This times this is going to be 0 because the coefficients are different. And so now, okay, so then cosine cube is going to be equal to 0. Okay. And what about cosine 5th? Cosine to the 5 power, right? It's going to be the same thing, cosine of x plus whatever, 1/2, 1 plus cosine of 2x. This is going to be squared, right? And we will end up having something like cosine x to the power 4. This is going to be like 1 plus 2 times cosine of 2x plus cosine square of this, which is going to be like 1 plus, I'm sorry, another half, technically. Another half 4x, right? Because cosine square of 2x is equal to this, right? And notice that, again, you still have cosine of x. Cosine of x is still going to be distributed here, and distributed here, right? Because this cosine x is still here. And so because of that, this is also going to be 0. So I guess for odd powers, they're going to be 0. Okay, cool, right? But then again, we have squares. We have squares here, and then there's a square here. Okay. So how do we do with this? So we have cosine. So pretty much we're left with this now. Okay, cosine square, cosine 4th, cosine 6th. Okay, so what do we do now? Do we expand it? Or you don't have to do periodicity here. Okay, you have other methods. Remember, you have other methods too, right? You could use you could continue using periodicity, but my fastest route here is to use Wally's product. Let u equal pi over 2 minus x. Okay, and then that's going to give me, well, from pi over 2, from negative pi over 2 to pi over 2. And that's going to give me sine square, sine 4, sine 6. This is all even functions from 0 to pi over 2. Oh, Wally's product. Look at this, right? So you don't have to use periodicity in this case, because thank goodness we can use Wally's trick. So by Wally's trick, we have, let's see, that's going to be like 1/2. I'm sorry. It's like pi over 2. They're all going to be they're all going to have pi over 2. I notice. So, and then we have 1/2 plus 1/2 times 3/4 plus 1/2 times 3/4 times 5/6. Right, if you do all the arithmetic, that cancels out. If you do all the arithmetic, you should end up with 19 pi over 16. Okay? So again, I used periodicity to cancel out the odd numbered cosines, and then for the squares, instead of using periodicity again, I could just go straight into Wally's trick. Okay? Are you ready for this one now? This is an MIT integral, a very infamous MIT integral. This one, we're gonna have to a little bit bashy here, because this is an ugly integral, I will say. But I think now is the time to really conquer some very advanced level periodicity here. Okay, so using Pascal's triangle, we know that this is going to come out like what, 1 minus 5c, 10c squared minus 10c cubed plus 5c4 minus c5, something like that. And then of course we have times cosine of 5 of x here, whatever. Okay, so I know this is going to cancel out. This is also going to cancel out. Here we have, let me actually go ahead and go here. So with cosine 5x, let me go ahead and simplify further. We're going to have half plus half of c 2x, right? And then, oh, okay, so this is also going to cancel out. Okay, that's also going to cancel out. And then minus 10c cubed, right? We have cosine of x of half plus half cosine of 2x, right? And of course, distributing this and this with all of this, that's also going to cancel out. Okay, nice. All right, we still have to check more. Okay, cosine fourth, that's going to be cosine 2x plus, oh, with a half squared, right? And we know this is going to equal to like 1 plus 2 cosine of 2x plus, and then more squared here, right? We're going to have another half, and then half on c4x, right? And then we're going to distribute 5x here, and this also equals to 0. Okay, what about cosine to 5x? Okay, cosine of 5x, we have cosine here. We have the cosine fourth that we just showed, right? We had like 5/4 of, I'm sorry, not 5/4, 1/4 of 3/2 plus 2 cosine of 2x plus 1/2 of cosine 4x, whatever. Okay, if we distribute, oh no, right, we have triple terms. Okay, we have triple terms. So whenever you have triple terms, you can't cancel out like how we did from the previous ones, right? Because, I mean, the previous ones, we only had like cosine times cosine stuff, right? Here, we actually have cosine times cosine times cosine. We have this, it's because of this. It's this extra cosine of x that gives us this triple term. Now, I will say this does cancel out though. This term will cancel out, but the rest won't. Okay, so let's be careful. We have to check triple terms, triple cosine stuff. So we have cosine of 5x, okay, times 1/4. And then we have also times cosine of x. And then, of course, we know obviously this term's going to cancel out because it's just going to be leaving with this. And now we have 2 cosine of 2x plus 1/2 of cosine 4x. Okay? Alright, let's clean this up. Okay. Whew. Alright. Some tough stuff now. We're getting into some very tough stuff. Okay. So, where do we go now? Okay, so we have these triple terms. Okay, let me go ahead and split this. All right, so this is 1/2. Okay, cosine times this cosine, we end up with cosine of 4x plus cosine of 6x, right, times cosine of 2x. Oh, okay, thank goodness. We're gonna, this cancels out. That's equal to 0. Okay, so this whole portion is equal to 0. Okay. So then plus whatever. So that whole term equals to 0. All right, so let's focus on this one now. 1/8 0 to 2 pi. Okay. And now we have, again, we have cosine 4x plus cosine 6x. Uh-oh, we do have cosine 4x. We have a square. Okay, but this term cancels out though. Okay, so what we end up is we have 1/16 over from 0 to 2 pi. And then we have cosine square of 4x, which is going to, whatever, half plus ... So we end up having 1/32 times 2 pi. And that's our answer. So our answer is pi over 16. Okay? Our answer is pi over 16. That is our answer. Okay? Now, again, a long process, right? That was a long process. This is exactly how periodicity is going to look like in an actual integration bee competition. Okay? So that's how we use periodicity. Notice how fast that was, right? Again, we still have to use some trig identity here, right? We still have to use some trig identity, but that's going to help us cancel more stuff out with other things. Okay? All right. Oof. Yeah. I know, it's a lot. But, you have to just practice it, get comfortable with it, and then you'll definitely become faster with periodicity. Okay? All right. I hope that was helpful. Thank you guys so much for watching, and I'll see you guys in the next video.